There, so continuing just right after the previous session on DevLog 18, let's jump into the next one. So we continue with those native symbols from WebGPU. So we've seen the minimal symbol. So if you remember, it's still just here. So whoops. If we render this one, it's just going to render a full screen quad, and this one was pretty simple because you don't have to pass anything to the pipeline, and you just request a rendering of 6 vertices, and that's all. The vertices were hard-coded into the shader program, and we just use the index. The next one we're going to see now is the square symbol. Just to clarify that, we're just taking them in the order here. I have not implemented the coordinate system example because at that time I kind of found that this one was a bit tricky to set up because it was already using textures, and yeah, I didn't feel that would be low level enough. It would probably be not that tricky anymore now, so I could revisit this one, but I don't think there's much to gain from this. So why was I not considering it? Yeah, I was probably just stopping because of this loading of the asset files. Anyway, so we've seen the minimal one, and now the square one, which is just going to render a square using vertex buffers. So let's see how we have implemented that in the end. So this one is a bit longer, but still not very long. We have 150 lines, and the initial version 350 in C. So you see that this one is actually, you have a lot of comments also maybe, but it's actually much more verbose, and you have a lot of local structures defined on that. So not something I would like to do on a day-to-day process. And that's the reason why I basically deviated from this kind of implementation, and I'm trying to optimize the engine to make it more user-friendly. And but we were still in very initial stages in this example. What do we have in there? We create a simple app context application, and we're going to override the setup app and render frame. We're going to build a render pipeline. We have a buffer for the position, another buffer for the colors. So we start with preparing the buffers, which is an helper function. And to prepare that, we're going to just provide a list of prop values, and we have this helper function create buffer, which just take your data, the size of data, and what kind of usage you want to have for this buffer, and it will generate a buffer for you. This is really just how can I display it? Okay, WGPU buffer object. So the raw low-level buffer from WebGPU, which is the same thing for the colors, and we create another buffer for that. And then we have the setup application function where we start by calling this application, and then we have the code that we use for the shaders. So we're going to accept the position and colors as input and produce some output with the position, the final position that we want to draw the pixel at in clip coordinates, and the fragment color that is going to be passed to the fragment shader. So we start with the input, just forward the color that was provided as input to the output, and which is the same thing basically for the position, because we expect the position to already be in clip coordinates in this case. For the fragment shader, we're just receiving that color. It's here, the input version, and we're going to just output the color again. A pretty tricky way of doing it, because you could just say that you want to output the color from here and just receiving the color from here. You don't really need the structures, I believe. Not that I believe, I'm pretty sure of it. Anyway, so we're going to just keep building the render pipeline as usual. I mean, as in the previous example, this function is just taking the vertex shader code and the fragment shader code by default. It's always so accepting additional parameters, I believe. But you can have default value for them, and we'll check what these are in later samples. And as I said, this is going to return a builder object, so you can keep adding stuff to that builder before generating the pipeline. The first thing we do is we have this add vertex buffer, which is going to just declare that you want to add the vertex buffer. Where do you add the vertex buffer? I have no idea. Why do you add a vertex buffer? Let's see what we do with that vertex buffer layout. You need a layout. Oh yeah, you need a layout because you need the list of buffers that are going to be accepted for the vertex state, okay, in the descriptor, which is used to create a pipeline. So yes, the pipeline must be aware of how many vertex buffer you're going to provide, which makes sense. So we define that we add this vertex buffer, and then we start defining what is in this vertex buffer. We're going to provide the position first, so we will just provide that as free float values. Then we had another vertex buffer, so a separated one then, and that's where we're going to provide the colors. So each of those buffers have different binding location, different binding number, and in the shader code they are going to be defining also location for what they contain. And this one, for instance, contains the position, and the other one contains the color. I'm not quite sure if you can mix like binding 0, location 0. I think in theory you should be able to do that, but at the same time I feel that I have tried that, and the compilation was complaining that location 0 was used twice or something. I might be inventing all that, I'm not really sure anymore, but that's something where I would be careful. Anyway, it's not a big deal to, in those early symbols at least, it's not a big deal to have binding 0 with location 0 and binding 1 with location 1. I'm not even really using any more than one single binding now, so most of the time we have just binding 0 with all the locations. So what do we do else? We specify that we're going to render triangle strips, because by default we're just going to use triangle list, and we call the front face. Ready? So we keep the back face, which means we're drawing the triangles in inverted order. I'm wondering what are the positions that I'm using. Okay, I could go into the mental gymnastic of figuring out what is the order of the triangles, but maybe it's not a good time to do it. Let's just bypass that. Let's just say that, okay, we need to kill the front face because we are actually showing the back face and drawing the triangle in actually that would be clockwise order right now. If we are drawing in clockwise order, by default the front face is counterclockwise. So front face would be counterclockwise, and if we want to call that, it means we are specifying the vertices in clockwise order. And okay, so after that we can create the pipeline, and then we go into the render frame function. We just do the same thing as in the previous sample. We just retrieve the swap chain, the current texture from the swap chain, and we start building a new color attachment with a clear color, which is completely black. And then we start recording the commands, and then we start a render path. There we set the pipeline that we want to use, that viewport and scissor as before, and then that's where we actually provide some new data. Now we need to provide those vertex buffers. So for the slot 0, that's going to be the position buffer, offset 0, and we provide the full buffer. Same thing for the slot 1, providing the colors this time, offset 0, and then we start drawing, and we will draw 4 vertices on a single instance, and that's it. Then we submit those commands and we present what we've just rendered, and that should produce a simple quad in clip coordinates. Take note also that the coordinates that we're providing here is 0.5, so it means it's not taking the full screen, it's basically just taking half of the screen. The Z position is 0, which means it's actually at the near plane, because in WebGPU we have near plane at 0 and the far plane at 1 in depth value. I mean in the clip space. Yeah, and that's it. So let's just try to render that, and we have 4 different colors here for the corners. So the name of this is simply square, I believe. Ta-da! Wonderful, isn't it? Okay, not much more was introduced in there. I'm not sure what we have introduced really. Sounds pretty similar to the previous one in the end. Just we're providing some additional details here, and we're actually providing a buffer. In the previous one there was no buffer, and we're providing even 2 buffers. Next one was a triangle. This one is where I started to introduce support for actual camera control. I already had a camera and a camera controller implemented in the base NV core library. So what I've done is just to provide an additional layer on top of that to be able to use the same camera object and the same matrix construction logic from there. So where do we add that? Let's just check the example first, and we'll see. It's a triangle. What do we do in there? The symbol itself is still reasonably long, not that long. We're going to do the same thing as usual, building a pipeline. We have a few buffers, and we have a bin group this time, and also we have this projection matrix and those uniform data that we're going to pass to the shader. Setup camera. So I think we're still using the very raw camera here, not quite the layer that I added above it of it later. So let's see. We start with preparing buffers, vertex buffer, index buffer. Index buffer, it just means that we're going to, it's a simple triangle, so it's just going to use vertex 0, 1, and 2, one after another. In the position buffer, I mean, it's not really position anymore because that's just providing all the data for each vertex at the same time. How do you call that? I don't know. You're mixing a buffer with all the attributes that you want for your vertices. So you have the position and the color, but you could also add the normal texture coordinate and so on. So yeah, here we still have just position and color. And what is different here is when you are building a buffer that is supposed to contain vertex data, you want to have this usage set to vertex. But if you want a buffer that is going to be used as an index source, when you do the render pass, the usage that you need is index. And another usage that you might have then is uniform. If you want a buffer which contains data that is going to be provided as uniform in your shader. So we'll probably have a look at that in the shader anyway. So then we have the setup camera, where I am actually setting my camera to look at the position 0, 0, 0, and it's a bit backward in the Z direction. So remember, Z is the direction going into the screen in WebGPU. So if you have negative Z, it means that you're going a bit backward compared to the initial world origin point. So your object will be in front of you and it will be in the negative Z part for the camera. Then you set the perspective to be about 60 degrees, sorry, and the aspect ratio to match what you have for your current window dimensions. Near and far plane. This is an error I always make, and the fact that I see that here remind me that I always have to keep that in mind. Very often when I'm starting this kind of project, I would tend to just set the near plane to 0, and you would say, yeah, why not? No, that doesn't work. Near to 0 is an error, because you are basically messing up your perspective matrix when you set that to 0. It must not be 0. So always put that to some minimal value, and then you have also the range between the near and the far that cannot be too large, because you have the precision of the values that you're using, so flop values in this case, that must be taken into consideration, but typically here that should be acceptable. So that's for the setup of the camera, which is also called sometime at the very beginning, I guess. What is that? Prepare buffer, prepares buffer, and then set up the camera, and then update the uniform buffer, because this uniform buffer is going to take the data that you have inside your camera and upload that on the GPU in the buffer. So what do we do in this update uniform buffer? You just retrieve your projection from your camera. You set that in this UData structure that we have defined in the class above. And one thing that is a bit of a mess, I must admit, is that my matrix class, if you recall, I said I didn't like to use GLM, so I have my own matrix class, and this matrix class is let me think, because I'm always mixing the two. I am row major, and WebGPU is column major. So yeah, we don't really agree. And whenever I have to upload a matrix for the shader usage, I need to transpose that matrix first, which is well, not really a free operation, but it's not really a big deal either. So I'm not really concerned about that for the moment. Anyway, I do transposition at this point. And just after that, when I have written everything I need in this structure, I'm going to write the data that we have in the structure into the uniform buffer, with again a function coming directly from the engine. So the engine is really this the WGPU engine class that I have, which is provided as an instance that we can retrieve anywhere in the code because we just have a simple call to get that. And what else do we have that is important to mention here? We're going to start building a bind group. Yeah, and also we have a def texture assigned here. Do we really need the def texture? I'm not sure for this example, but anyway, we have created that, and I think I'm probably using that to assign it to the render pass. So let's see what we do with create render. Oh, maybe I should mention that also render pass. In the previous example, previous was the square. Yeah, I was still building the pipeline like that, and then when it comes to render frame, I was basically encoding the commands and creating a render pass in there and doing what I need to do with the render pass before finalizing the commands. Now, for this new example, I have moved to creating a dedicated render pass class, which is this kind of object here. So you can do create render pass, and that's going to create a new render pass for you. And that's basically how I'm now setting up everything I need to do a render pass without really doing it yet. So it's just pre-recording all the steps that you need. So you can attach a def texture, for instance, with this function, then add swap chain color attachment. That a trick I'm using to automate the retrieval of the swap chain and the current texture from that swap chain, and the assignment of that current texture as a color attachment for this render pass, just before we start doing the actual operation, like setting up the pipeline and rendering with a dual call or stuff like that. So it's covering what we have at the beginning in there with retrieving the texture, creating a color attachment, and then preparing the render pass info with this color attachment. And that's what you need actually to create your actual render pass. Okay, so that's that's how we set up swap chain. Then I started with this encode function. This one will provide you with the render pass encoder, and you have to define a function that will take this encoder and perform all the steps that you need. So you set the pipeline, your bind group in this case. So bind group is not really, we have not really seen that yet. We'll get back to it. The viewport, vertex buffer, index buffer, and then you start drawing index in this case because we have an index buffer. So we use index buffer to get the location of the vertices that we need to draw, and we're going to draw only 3 vertices. So we're using 3 indices because that's just a triangle. And this encode function is then what we're going to do to call later when it's time to do the actual rendering with this render pass. Another thing here is when I call create render pass in my engine, I'm also actually keeping track of this render pass internally because I have a map or a vector, not sure anymore, probably a map. So assigning a number to this render pass. So the first time you call create, let's see what we're doing. I'm not sure anymore if it's you're returning that, okay. Creating render passes, add. Yeah, I think that's a kind of a bit of a smart container. Render passes here, you can add object to it, and it's going to place that in a vector, but you can also remove object from this container. So it's going to free some slots in this vector. And then the next time you're going to add something in this vector, instead of keeping increasing the size of the vector, it's going to reuse one of those slots that were previously removed. So then you can get a slot number assigned to the object that you put in that slot. So, and I'm basically not returning that here, but this object should in fact contain the number that it's supposed to be assigned to it as a slot number. So if we go and have a look at the definition of this class, it's based on the WGPU object, and this one, yeah, you have an ID which is an always increasing number, but you add this ref index and you have this function set ref index, which is called basically by this container to say that, okay, this object is stored in this slot, and then you can retrieve this number with get ref index, which I'm just not doing anywhere, but it's possible to do it. So the fact here is, since it's the first render pass that I'm creating, it's going to be stored in the slot 0, and I know that. Okay. So this is it basically for this new mechanism I'm using now to prepare the render pass before actually using it in the render function. And another thing I didn't really cover yet is this bind group construction system. So we have now another builder, which is a bind group builder. So I think that's what we get there, yes. And at first I was actually trying to define builders with a single ID. Like for this one, the ID is going to be default. And we keep track of those builders internally in the engine. Now, I must admit that I'm not convinced anymore that I really need to keep track of them, because usually it's a one-shot usage. I mean, what I've been doing so far are more one-shot usage. So maybe it's not useful to have this inside the engine itself. So might have to change that eventually. But anyway, you just create a builder, and then you retrieve that builder and you start defining what is available in this bind group. I mean, it's a bit tricky, because to build the bind group, you have to build first a bind group layout, which is really telling you, okay, for this bind group, you're supposed to have this kind of content and this kind of content. So you have multiple entries. So it's defining what kind of entry you can have. It could be a buffer for the first entry, for instance, which will be used as a uniform buffer. Then the next entry could be a texture sampler. Then the next one could be a texture view itself that you want to use with the sampler. And so on. You can have multiple entries like that. So you can first define what is going to be the layout for each group that you want to build, and then you have to actually provide some data to build a group following this layout. So we have two kind of functions, as you see here. We have this add uniform buffer, for instance, which is going to define that in the layout we have a first entry, which is a uniform buffer with a given size, but it's not actually, well, binding any uniform buffer yet. Then you can create a uniform buffer using this layout that you just defined with this set uniform buffer, and that's where you actually inject your data into what you're constructing as a new bind group. Sorry if this is not clear. I mean, this is basically how I understand it. Might be completely wrong. I mean, not completely wrong because there's still some truth in there, but maybe not so clear. So sorry about that. Anyway, you can build your bind group like that. So the builder, you first define your layout, and then you can start building bind groups using those layout. And again, we have this call operation that is going to create an actual bind group using really the latest layout that you have defined, because you can actually build multiple groups with this builder. And yes, this is some additional layer of complexity, in fact. But anyway, let's keep it simple. Here in this case, there was a single group, so just single element to define, and then single assignment. We could still have added multiple stuff in the single group that we have, and then connecting multiple stuff to build one group. And in this, what? Why? What the? Okay, not quite sure why, but my computer decided to shut down on its own. Now it's back on, and so we can continue where we were, sorry. Except that this recording is already pretty long, so let's just finish with this triangle example. So we've been using in this case, I think I was here, we're using Spear 5 compiled shader instead of what? WGSL, yes. So we can we have support for that also. When you build a render pipeline, the code that you're providing here could have been read from Spear compiled file. So we just specify that it's going to be Spear v here, and also we have added this add color target. Because otherwise we were doing that manually, I believe. No? It's interesting. In the pipeline here, I don't have a color target added. Oh, actually this is completely encapsulating. Honestly, I'm not quite sure anymore what I'm doing with this. Add color target color target on the builder, okay? So you have the blend operation, color target, fragment. Oh, it's because for your fragment shader you need to define what are going to be your targets. True. So that's where this is coming from. So you tell that when you render your fragment shader, you want to render to that target. Do you kind of get the index of the target or something? Color target pushback. Where do we have as a color target pushback state? Color target state format. Do we have an ID or whatever? Oh, I mean, you're supposed to. Okay, depending on how many color attachment you then provide in your render pass, you're supposed to define as many color target settings for your render pass, because the fragment shader could be rendering to the first target or the second target or none of them. So that's why you would have this right mask in the blend settings for all the targets, all the color targets at least, that are attached to your shader. That's really tricky, isn't it? Anyway, back to the triangle again. Is there anything else we need to cover in there? So we have set the layout. That's another big thing. When you build a render bus, you have also to provide the bind group layout to it. Before building the, when I said when you build the render bus, I think, sorry, when you build a pipeline, you have to provide the bind group layout inside the pipeline layout to build your pipeline. But this bind group layout really depends on what you're going to provide as input then, and that's something you want to build completely elsewhere. And that's why, this is really built here with this bind group builder. And that's why I started with this recording of those builders. So there's this ID which is attached to this specific builder where you have a layout for first group, and you can then access this builder from the engine itself and ask it, okay, what is your layout for your groups, all your groups actually. And this is what is happening here. You're going to retrieve the layout, the bind group layout from this builder, and assign that to build your pipeline. And then we go with defining another vertex buffer with some content in there, except that we only have one vertex buffer this time. We enable blending for this pipeline. Depth stencil also is enabled. And that's it. We just create a pipeline afterwards. And next thing, yeah, we have mentioned already. We create the render pass, blah, blah, blah. Pre-recording the rendering. It's not really pre-recording, it's just with building the function here only once, but it's still going to call this function every time you do the render frame. And here you're going to request to start building commands. So we also have now a command builder. Same logic as for the pipeline builder or the bind group builder. You get the object. You can chain multiple calls on it, and eventually you call a function to perform the operation you want with all the modification that you provided, or the default value if you didn't provide stuff that is needed. So here we start building the commands, and we request the rendering of the pass number 0, because number 0 I know is going to be the ID assigned to this render pass, because it's the first pass I'm creating anyway in the engine. If I get more passes eventually, I'll probably need them more. Yeah. I don't know how I'm going to do that exactly, but I need something more robust to find the render pass, of course. And anyway, then we're going to submit those commands and present the result. So let's see what this is looking like, and we're probably just going to stop here for this recording also. So this is triangle. Ta-da! And it's not moving. Yes, right. Because this is actually where I started to think, okay, using, what is the library again? GLFW as a library to do the display as we do here is nice and great and all, and a lot of people are doing that. But I don't really have support here for interaction with the mouse and any kind of event handling like resizing and all. It's still resizing fine because it's actually stretching. You don't really notice that maybe because the display quality is not changing a lot, but it's not really changing the rendering size. It's just stretching the texture that is rendered still in a small size. But anyway, I didn't really want to rebuild the mouse handling, keyboard handling, and everything like that with GLFW, because I already have all this built and pretty, it's not really complete, but it's usable with SDL and SDL2, and SDL2 is actually more complex, more evolved, and there's more stuff in there than in GLFW. So starting from this example, I then decided, okay, it's time to move to SDL2 as a windowing system. And I just decided to rebuild exactly the same example as this one in SDL. But we're going to cover that in the next recording. We have that actually mentioned in there. So yes, we have built a triangle. As I said, in my case, I need to transpose the matrices. I didn't mention anything more, but then yeah, we have this one, the SDL re-implementation of the triangle example, specifically to get the camera control support working directly without re-implementing everything from scratches. Anyway, so thanks for watching and see you in the next session then. Bye bye.